Echolocation in bats. An analysis of echolocation in bulldog bats. Imagine walking through a cave. As you walk through the depths of the cave tunnels, you release a loud holler. Moments later, the same holler is repeated back to you in the same pitch as the initial holler. This is the basis of an echo, specifically echolocation. In a sense, echoes are merely the reflection of a sound off of a distant object as they bounce off of them. However, it is evident that echoes are only perceivable in certain types of locations or surfaces. In smaller rooms or areas, an echo is unlikely to be heard or perceived. In contrast, mountains, tunnels, caves, and wells are likely to release an echo as the sound is able to carry a significant magnitude that allows it to return subsequently after to the listener. Unlike humans, bats are able to see through the use of sound. In other words, their vision resides in the perception and processing of sound waves emitted. Though a common misconception is that bats are blind, this is not necessarily true. In contrast, the bats are able to use sound as a sight mechanism in total darkness. Specifically, bats create ultrasonic waves through their larynx and release them through their noses and mouths. The clicking of their complex tongues enables them to release sounds used to determine their surroundings. They process the timing of an echo along with any frequency changes in order to determine where they are in the moment and what is near them. There are two types of echolocations found in bats: low-duty cycle and high-duty cycle echolocation. Low-duty echolocation is based on the perception of the sound and the time in which it returns back to the bat. In contrast, the high-duty echolocation is centered around determining their prey's location and their movements. By the emission of an extremely high-pitched sound, they are able to detect any slight changes in the frequency when it is reflected back to them. One species of bat that utilizes echolocation is the Noctilio leperinus, commonly known as the bulldog bat. The bulldog bat is a unique species as it possesses many physical and behavioral adaptations that enable them to collect food and other resources for survival purposes. One unique characteristic that they carry is the consumption of fish, crustaceans, frogs, and water insects. These bats are able to locate the ripples and changes in the water patterns through echolocation, ultimately guiding them to their prey. The common bulldog bat is about 9 centimeters long with a wingspan of about 40 to 44 centimeters. In contrast, the smaller bulldog bat ranges from about 11 to 12 centimeters with a 70 centimeter wingspan. Colors of its fur coat ranges from red to brown to orange. In addition, they are known for having a white stomach. They secrete an oily substance that is used as a water repellent that covers their large tails and wings. At dusk, groups of these bats zigzag over the water approximately 20 to 50 centimeters above in search of potential sustenance. When they locate a potential source of food, they descend upon the water and use their talons to grapple onto the fish, for instance. Ultimately, they store whatever they caught in their cheek pouches and save it while continuing their fishing expedition. Echolocation is used to prevent multiple bats from colliding. In a sense, they are able to adjust their communication between one another in order to prevent harms towards one another. In other words, these bats honk at each other in order to prevent a collision. This honk is created by lowering the octave of a frequency call. As a result, the bats are able to avoid or veer to the side to prevent the inevitable impact that would occur. In all, the bulldog bat is able to utilize echolocation for multiple purposes, including searching for food and protection from other bats. This feature is instrumental in their lives. Without it, they would not be able to sustain themselves, and ultimately, they would perish.